Tonight, we're going to talk about weather. Not the weather outside your window, not rain or wind or clouds you recognize, but weather as it exists across the solar system. Because weather is not something unique to Earth. It happens wherever energy meets atmosphere, where sunlight arrives, and a planet decides what to do with it. Every planet in our solar system receives light from the same sun, the same source of energy, the same quiet warmth traveling through space. And yet, each world responds in its own way. Some planets trap heat until nothing can escape. Some release it through storms that last for centuries. Some remain silent for years, until the entire planet disappears beneath a single storm. There is acid rain on one world, winds faster than sound on another, storms shaped like perfect geometry, weather that never changes, and weather that never ends. Tonight is not about extremes. It's about understanding how planets breathe, how they release energy, how they find balance, or fail to. This journey is slow. There is nothing you need to remember, nothing you need to stay awake for. You can simply listen and let each planet reveal itself quietly. And if calm science journeys like this help you relax or fall asleep, you're welcome to subscribe to Astri X, where we explore the universe gently, one quiet story at a time. Now, let's begin with the simple question. What is weather when Earth is no longer the reference? Before we look outward, before we imagine alien skies and unfamiliar storms, it helps to pause for a moment and consider something that feels ordinary only because we live inside it every day, something so familiar that it almost disappears from awareness. And that something is weather. Not as a forecast or a temperature on a screen, but as a quiet, constant process shaping life on Earth. Weather on Earth feels simple because it is close, because it repeats, because it has patterns we recognize. Mornings that warm slowly, afternoons that peak, evenings that cool, nights that allow the planet to release what it gathered during the day. And this daily rhythm is so reliable that we rarely stop to wonder why it exists at all. At its core, weather is not about clouds or rain or wind. It is about energy, about what happens when sunlight arrives at a planet and how that planet responds, how it absorbs warmth, how it stores it, how it moves it, and eventually, how it lets it go. Every second, the sun sends energy across space, a steady stream of light traveling millions of kilometers until it reaches Earth. And when that energy arrives, it does not land evenly. Some places receive more, some less. Some surfaces warm quickly, others slowly. And this uneven distribution is where weather begins. Warm air becomes lighter and rises. Cooler air becomes heavier and sinks. Pressure differences form quietly, and the atmosphere responds by moving, flowing, adjusting, always seeking balance but never fully reaching stillness, because energy is always arriving. Earth's atmosphere is thick enough to slow the escape of heat, but thin enough to prevent that heat from becoming trapped forever, and this balance is delicate, shaped by billions of years of evolution, a narrow window where temperatures remain stable enough for water to exist as ice, liquid, and vapor. Water changes everything. It absorbs heat slowly and releases it slowly, smoothing extremes, softening transitions, allowing warmth to linger after sunset and cold to ease after sunrise. And because so much of Earth is covered by oceans, this buffering effect reaches across the entire planet. Weather, then, becomes a system of movement rather than accumulation. Heat rises and spreads, moisture evaporates and condenses, clouds form and dissolve, rain falls and returns to the sea, and nothing remains locked in place for long. Even Earth's most powerful storms are temporary. They form, intensify, release energy, and fade. This impermanence is one of Earth's greatest strengths. It allows recovery. It allows life to adapt. It allows balance to reassert itself again and again. Earth's rotation adds another layer to this quiet complexity. As the planet spins, air currents curve, winds bend, storms rotate. Not because of intention, but because movement across a rotating surface creates subtle forces that shape large-scale patterns, guiding trade winds, steering jet streams, and gently organizing chaos into something recognizable. The tilt of Earth's axis stretches this process across time. Seasons emerge not because the sun changes, but because Earth presents itself differently throughout the year, sometimes leaning closer, sometimes leaning away, redistributing energy slowly rather than all at once, preventing the planet from overheating or freezing entirely. This tilt introduces rhythm. Summer gives way to autumn, autumn to winter, winter to spring, and each transition is gradual, predictable, survivable, allowing ecosystems to prepare rather than react. Weather on Earth is rarely constant. It changes hourly, daily, seasonally. This constant change prevents stagnation. It refreshes soils, cycles nutrients, shapes landscapes, and influences where life thrives and where it struggles. Mountains redirect air masses, forests influence humidity, ice reflects sunlight back into space, deserts release heat quickly after sunset, coastlines moderate temperature swings, and all of these features interact without coordination, yet somehow produce a system that feels coherent. This coherence is not perfection. Earth experiences floods, droughts, heat waves, cold snaps, storms that disrupt and destroy, but even these extremes exist within limits. They arrive, they pass, they leave space for renewal. Earth does not allow energy to build indefinitely. It releases pressure gradually. This release is what keeps the system alive. Weather, in this sense, is Earth breathing. Energy in, energy out, day after day, year after year. This breathing allows stability without stillness. Life evolves inside this motion. Plants synchronize growth with rainfall and temperature. Animals migrate with seasons. Human societies form around predictable patterns of warmth and cold. Planting and harvesting aligned with rhythms that feel natural because they are. Even rest is shaped by this system. Darkness cools the surface, signals bodies to slow down, allows the planet and its inhabitants to reset. Weather is not separate from life. It supports it, but this familiarity can be misleading because Earth's weather feels normal only because we have never lived anywhere else. When we step back and consider the broader solar system, Earth's behavior begins to look unusual, even rare. Earth does not trap all incoming heat, nor does it lose it too quickly. Earth does not spin too fast or too slow. Earth's atmosphere is neither crushingly thick nor almost non-existent. These balances are not guaranteed outcomes. They are specific results, and weather is the visible expression of those results. Weather tells us how a planet manages energy. On Earth, energy arrives, moves, and leaves in a continuous loop. On other worlds, that loop breaks. Sometimes energy accumulates without release. Sometimes it escapes before it can be distributed. Sometimes the atmosphere becomes so thick that storms cannot exhaust themselves. Sometimes it becomes so thin that weather barely exists at all. Earth sits in between. It occupies a narrow middle ground where motion is constant but survivable, where storms are powerful but finite, where change happens slowly enough for life to respond. This is why Earth feels calm compared to other worlds. Not because nothing happens. Weather ends. Storms fade. Heat disperses. This ending is essential. A planet where weather never ends becomes hostile. A planet where weather never begins becomes barren. Earth allows both movement and rest, and this balance sets the stage for everything that follows. When we compare Earth to other planets, we are not asking why their weather is strange. We are asking why Earth's is gentle, why Earth avoids extremes, why Earth remains habitable. Understanding Earth's weather is not about memorizing facts or patterns. It is about recognizing balance, recognizing that weather is the planet's way of responding to energy without breaking under it. This understanding becomes our reference point, because once we leave Earth behind, once we move outward into the solar system, we will encounter atmospheres that behave differently, worlds where storms do not end, where skies never clear, where heat is trapped endlessly or lost immediately, and where weather becomes something entirely unfamiliar. But for now, Earth remains the quiet example. A planet where energy flows rather than accumulates. A planet where weather changes rather than persists. A planet where balance allows rest. And it is from this calm foundation that the rest of the journey begins. As we move away from Earth, the familiar balance begins to loosen, not suddenly, but gently, as if the solar system itself is inviting us to notice how fragile and specific Earth's calm truly is, and how easily weather can become something entirely different when even one condition changes. The sun remains the same. It continues to shine steadily, sending energy outward in all directions without preference, without intention, without awareness of where that energy will land. And yet the worlds that receive it respond in profoundly different ways, not because the sun changes, but because they do. Distance matters, gravity matters, atmosphere matters, rotation matters. And when these factors shift, weather transforms. As we travel inward toward the sun, the first world that truly challenges our understanding of weather is Venus, a planet often described as Earth's twin because of its similar size and composition. Yet nothing about Venus behaves like Earth, and nowhere is that difference more complete than in its atmosphere. Venus receives more sunlight than Earth, but not enough to explain what happens there. The true difference lies in what Venus does with that energy once it arrives. Venus is wrapped in an atmosphere so thick, so dense, that it traps heat almost completely, allowing sunlight to enter but preventing warmth from escaping. And over time, this imbalance compounds not explosively, but relentlessly, until the entire planet becomes uniformly hot. There is no nighttime relief. There are no seasons in the way Earth understands them. The surface temperature on Venus remains almost constant across the planet, hot enough to melt lead, not because the sun is violent, but because the planet never releases what it receives. Weather on Venus does not cycle. It stagnates. Clouds on Venus are not made of water. They are made of sulfuric acid. Thick, layered, opaque clouds that reflect most visible sunlight, yet still allow enough energy to reach the surface to maintain extreme heat below. Above these clouds, winds race around the planet at incredible speeds, completing a full rotation in just a few Earth days, while the surface itself rotates extremely slowly, creating a strange disconnect where the atmosphere seems almost detached from the planet beneath it. This phenomenon is called superrotation, and it is unlike anything on Earth. On Venus, the atmosphere moves faster than the planet itself. Weather, if it can still be called that, becomes global and permanent. There are no storms that pass. There are no systems that exhaust themselves. The same conditions persist everywhere, all the time. If Earth's weather feels alive because it changes, Venus's feels frozen because it does not. There is motion, but no renewal. There is movement, but no release. Lightning has been detected in Venus's clouds, flashes of energy hidden inside acid-filled skies, but these flashes do not signal storms that bring relief. They are simply symptoms of a system under constant pressure. The winds never stop, the clouds never clear, the heat never fades. Weather on Venus is not a conversation between surface and sky. It is a monologue. Energy arrives, and the planet holds on to it. This makes Venus an example of what happens when balance is lost, not through chaos, but through permanence. A system that never resets becomes hostile, not because it is violent, but because it is unchanging. Life, as we understand it, cannot adapt to conditions that never vary. There is no cycle to synchronize with, no rhythm to follow, no rest. Venus shows us that weather must be allowed to end. Without endings, weather becomes climate-locked in one extreme state. As we move outward again, away from Venus and toward Mars, the lesson reverses completely. Where Venus holds too much, Mars holds almost nothing. Mars is smaller than Earth, with weaker gravity, and over billions of years much of its atmosphere escaped into space, leaving behind a thin veil of gas incapable of holding heat for long. Sunlight reaches Mars, but warmth quickly radiates away. Daytime temperatures can rise modestly, but nights plunge into deep cold. Weather on Mars exists, but it is fragile. The atmosphere is too thin to sustain frequent clouds, too dry for rain, too weak to buffer extremes. And yet, when weather does occur, it can become global. Mars is famous for its dust storms, vast systems that can grow large enough to engulf the entire planet, obscuring the surface for weeks or months at a time, driven not by moisture but by fine particles lifted into the air by sunlight and wind. These storms are not permanent. They rise, expand, and eventually collapse as energy disperses. But while they last, they redefine the planet. Sunlight is blocked, temperatures drop. Solar-powered missions fall silent. Mars demonstrates another boundary. A planet can have too little atmosphere to sustain gentle weather, yet still experience rare, dramatic events. Weather on Mars is intermittent. Long periods of stillness punctuated by episodes of planetary change. This kind of weather creates uncertainty rather than rhythm. Life, if it ever existed there, would have faced long stretches of inactivity, followed by sudden disruption. Between Venus and Mars, we see two extremes. One planet traps energy until it overwhelms everything. The other loses energy so quickly that stability becomes impossible. Earth sits between these worlds not by coincidence, but by balance. But the story does not end with rocky planets. Beyond Mars, we encounter worlds where weather becomes something even more alien, where surfaces disappear, where storms grow larger than continents, and where time itself feels different. The gas giants do not have solid ground in the way Earth does. Their atmospheres deepen gradually, layer by layer, until gas becomes liquid, and liquid becomes something stranger still. Weather on these planets does not interact with land. It interacts with pressure, with depth, with gravity. On Jupiter, the largest planet in the solar system, weather becomes monumental. The sun's energy is no longer the primary driver. Jupiter generates internal heat, left over from its formation, rising from deep within the planet, and feeding storms that can last for centuries. The Great Red Spot is the most famous example, a massive storm larger than Earth itself, rotating steadily for hundreds of years without dissipating. On Earth, storms end because they lose energy. On Jupiter, storms persist because energy is continuously supplied from below. There is no land to slow them down, no friction, no seasonal reset. Weather on Jupiter becomes a permanent feature rather than a passing event. Bands of clouds wrap around the planet, each moving at different speeds, creating sharp boundaries where winds shear violently, yet remain stable over time. Lightning flashes within these storms, deeper and more powerful than anything seen on Earth, hidden beneath thick layers of gas. Saturn, similar in composition but different in detail, reveals weather that is both powerful and strangely precise. At its north pole, a massive hexagonal storm rotates with near-perfect geometry, a shape that has remained stable for decades, defying expectations and reminding us that weather can organize itself into forms that feel almost artificial. This is not chaos, it is order emerging from motion. Farther out, Uranus and Neptune push weather into even colder, darker regimes. Uranus rotates on its side, creating seasons that last decades, exposing entire hemispheres to continuous sunlight or darkness, and the atmosphere responds slowly, reluctantly lagging behind these changes in ways that scientists are still trying to understand. Neptune, despite its distance from the Sun, hosts the fastest winds in the solar system, reaching speeds far beyond any storm on Earth, driven by internal heat and pressure gradients rather than sunlight. These worlds demonstrate that weather is not tied to comfort, familiarity, or life. It is tied to physics, to how a planet manages energy, to whether that energy is trapped, released, or redistributed. The farther we travel from Earth, the clearer this becomes. Weather is not universal. It is contextual. It reflects the history, structure, and behavior of each planet. Earth's weather feels gentle because Earth allows energy to flow. Venus locks it in, Mars lets it escape, the gas giants generate their own. None of these outcomes are mistakes. They are consequences. And in understanding these consequences, we begin to see weather not as something that happens to planets, but as something planets create. Weather is a signature, a fingerprint of balance or imbalance. And as we continue outward through the solar system, this signature becomes increasingly strange, increasingly unfamiliar, reminding us that the calm we experience on Earth is not the default state of worlds, but a rare alignment of conditions that allows change without destruction, motion without permanence, and weather that comes and then lets go. As the journey continues outward, the idea of weather begins to loosen even further from anything familiar, stretching into scales of time and size that make Earth's storms feel brief and delicate, and it becomes clear that on these distant worlds, weather is not something that passes through a place, but something that defines it entirely. On the gas giants, there is no ground to interrupt the motion of air, no forests to slow winds, no mountains to redirect storms, only layer upon layer of atmosphere deepening endlessly, where pressure increases gradually and the boundary between sky and planet dissolves into a continuous descent. And in this environment, weather becomes vertical as much as it is horizontal. Jupiter's atmosphere is arranged in bands that circle the planet, alternating in color and direction, each band moving at a different speed, sliding past its neighbors in a constant state of tension. And these bands are not surface features, but deep atmospheric rivers, extending thousands of kilometers downward, shaped by rotation, gravity, and internal heat rising from the planet's core. The Sun still contributes energy here, but it is no longer the dominant force. Jupiter radiates more heat than it receives, slowly releasing energy left over from its formation. And this internal warmth feeds storms that do not depend on sunlight or seasons, storms that are born from pressure and motion rather than evaporation and condensation. The Great Red Spot is the most visible expression of this system, a vast rotating storm that has existed longer than any human civilization. Its persistence challenging the very idea of weather as something temporary, and instead suggesting that on some worlds, weather can become a permanent structure, as stable as a mountain range would be on Earth. Within this storm, Winds reach extraordinary speeds. Clouds rise and sink through different layers of atmosphere. Chemical reactions tint the sky red and orange, and lightning flashes deep within, hidden far below the visible cloud tops, all of it unfolding slowly, continuously, without beginning or end. On Earth, storms are fueled by contrast, warm air rising against cooler surroundings, moisture condensing and releasing energy. But on Jupiter, the contrast exists between layers of pressure and heat, between rising internal warmth and the cooling of space above. And this contrast does not disappear when a storm releases energy, it is replenished from below. This is why Jupiter's storms do not exhaust themselves. There is always more energy waiting. Saturn shares much of this behavior, yet expresses it differently, as if the same physical rules are interpreted through a different rhythm. And nowhere is this more striking than in the hexagonal storm at Saturn's North Pole. A massive wave pattern locked into a six-sided shape that rotates with near-perfect precision. This structure is not imposed from outside. It emerges naturally from fluid dynamics, from the interaction of rotation speed, atmospheric depth, and temperature gradients. And once established, it remains stable, persisting year after year, as though the planet has discovered a pattern that satisfies its need for balance. This kind of weather feels almost deliberate, not chaotic or violent, but ordered, self-sustaining, and strangely calm despite the immense energies involved. Lightning storms on Saturn can encircle the entire planet, vast flashes that illuminate the atmosphere from within, lasting for months. Yet even these storms follow predictable cycles, rising and fading as internal conditions shift, not as the sun dictates. As distance from the sun increases, temperatures fall, light grows dimmer, and yet weather does not disappear. Instead, it transforms again. Uranus presents one of the most unusual cases, not because of what its weather looks like at any given moment, but because of how slowly it changes. Uranus rotates on its side, its axis tilted so extremely that entire hemispheres face the sun continuously for decades, followed by decades of darkness, creating seasons unlike anything else in the solar system. One might expect violent transitions between these extremes, yet Uranus remains strangely subdued for long periods, its atmosphere appearing calm, almost featureless, as if resisting change rather than embracing it. This calm, however, is deceptive. Uranus's atmosphere responds to sunlight with immense delay, absorbing energy slowly and releasing it even more slowly, so that the most dramatic weather often appears long after seasonal changes have already occurred, suggesting that the planet stores energy deep within and releases it on its own schedule. Storms can suddenly emerge, massive and bright against the pale blue atmosphere, then fade again into quiet, leaving long stretches of stillness behind. And this delayed response reminds us that weather does not always mirror incoming energy directly. Sometimes it reflects how long a planet is willing to hold on to that energy before letting it go. Neptune, farther still from the Sun, defies expectations entirely. Despite receiving only a small fraction of the sunlight that reaches Earth, Neptune hosts the fastest winds ever measured in the solar system, racing across the planet at speeds exceeding 2,000 kilometers per hour, driven not by solar heating, but by powerful internal energy and sharp temperature contrasts deep within its atmosphere. Dark storms appear and vanish on Neptune, immense systems forming rapidly and dissolving just as quickly, as if the atmosphere itself cannot settle into long-term patterns, constantly reorganizing, constantly releasing energy in bursts rather than steady flows. They are part of the planet's normal behavior. Weather on Neptune is restless, dynamic, and unpredictable, shaped by forces that have little to do with sunlight and everything to do with internal structure and pressure. Across these giant worlds, a pattern emerges. Weather is no longer tied to daily cycles. It is no longer constrained by seasons. It is no longer limited by surfaces. Instead, it becomes a manifestation of deep planetary processes, rising from within and stretching outward, responding to gravity, rotation, and heat in ways that feel almost geological rather than atmospheric. Storms become features, winds become rivers, clouds become layers, time stretches. On Earth, weather connects us to the present moment. On these worlds, weather connects to deep time. Centuries pass without meaningful change. Patterns persist beyond observation. The idea of forecasting becomes almost meaningless when systems last longer than lifetimes. And yet, despite these extremes, the same fundamental principle applies everywhere. Weather exists because energy must move, whether that energy comes from the sun or from within the planet, whether it is trapped or released, whether it flows gently or violently. Weather is the expression of imbalance seeking resolution. And Earth resolves imbalance quickly. Venus refuses to resolve it. Mars cannot hold it. The gas giants generate it continuously. Each outcome tells a story about the planet's structure, history, and limits. As we look across the solar system, weather becomes a diagnostic tool, a way to read the inner life of a world without touching it, without landing, without drilling, simply by watching how its atmosphere behaves, how it moves, how it refuses or allows change. A silent communication between a planet and space. And as this realization settles, the idea of weather as something familiar begins to dissolve. What we experience on Earth is not weather in its purest form. It is weather constrained, softened, filtered through conditions that favor moderation. Elsewhere, those constraints fall away, and weather reveals its full range, from permanent infernos to centuries-long storms to winds that outrun sound itself. Yet even here, there is no chaos without reason. Every storm obeys physical laws. Every pattern emerges from balance, even when that balance looks alien. The solar system is not a collection of random climates. It is a spectrum of responses, each planet answering the same question in a different way. How do you handle energy? How do you release it? How do you survive it? Earth's answer is gentle, others are not. And in understanding this contrast, the calm of Earth's weather begins to feel less ordinary and more extraordinary. A quiet achievement rather than a given, a narrow window where motion does not overwhelm life, where storms pass, where skies clear, and where balance, though never perfect, is allowed to return again and again. This is what weather reveals when we stop seeing it as background noise and begin to see it as planetary behavior, unfolding slowly, relentlessly, across worlds shaped by time, distance, each one telling its own story through the movement of air, the flow of energy, and the silent persistence of atmosphere responding to the sun in its own way. As the distance from the sun continues to increase and familiar reference points begin to fade, weather stops feeling like a surface phenomenon and starts to reveal itself as something deeper, something rooted not in clouds or storms alone, but in the internal structure of worlds, in how planets store energy, how slowly they release it, and how long they are willing to hold imbalance before allowing motion to correct it. And in this outer region of the solar system, weather becomes less about change and more about persistence. The ice giants exist in a realm where sunlight is weak, where days are long, and where warmth arrives reluctantly. Yet despite this scarcity of solar energy, their atmospheres remain active, restless, and in some cases extreme, reminding us that weather does not require abundance, only difference, only contrast, only the presence of energy seeking a path from where it accumulates to where it can finally escape. Uranus appears at first glance to be quiet, almost indifferent, its pale blue atmosphere smooth and understated. And for a long time, this calm puzzled scientists, because Uranus should, by all expectations, display dramatic seasonal changes, rotating as it does on its side, exposing one hemisphere to decades of continuous sunlight while the other remains in prolonged darkness. A configuration that seems designed to create extremes, yet Uranus resists them, holding on to energy slowly, responding with hesitation rather than urgency, as if the planet itself is reluctant to react. This delayed response reveals a different rhythm of weather, one that does not align with immediate cause and effect, where sunlight does not translate directly into storms, and where atmospheric motion lags behind seasonal forcing by years or even decades, storing heat deep within and releasing it only when internal thresholds are crossed, producing storms that feel sudden, not because they are violent, but because they arrive long after the conditions that created them have already passed. Weather on Uranus teaches us that atmosphere can have memory, that it can remember energy long after the source has shifted, and that release does not need to be immediate to be inevitable. Neptune, farther still from the Sun, abandons restraint entirely, presenting one of the most dramatic contradictions in the solar system. A planet that receives very little solar energy yet exhibits the fastest winds ever measured, an atmosphere in constant motion, streaked with dark storms that appear and disappear without warning, driven not by sunlight but by powerful internal heat escaping from the planet's depths. Neptune radiates more energy than it receives, and this excess must go somewhere, and so it flows into motion, into wind, into turbulence that races across the planet's surface, unconstrained by land, unmoderated by seasons, forming weather that feels alive in a way Earth's storms never quite achieve, not because they are more frequent, but because they are unbound. Here, weather is not a cycle that repeats predictably, but a system that continuously reorganizes itself, creating storms that grow rapidly and vanish just as fast, leaving behind no stable patterns, only motion, only change, only the constant search for balance that never fully arrives. Across these outer worlds, a new understanding of weather emerges, one where time stretches, where response is delayed or exaggerated, where the atmosphere behaves less like a thin shell and more like a deep ocean of gas, layered, pressurized, and endlessly dynamic. Weather becomes an extension of planetary identity, a direct expression of mass, rotation, composition, and history, rather than a temporary condition imposed from above. What these planets reveal is that weather is not merely an interaction between surface and sky, but a manifestation of how deeply a planet can hold energy and how quickly it is willing to let it go. And when that release is slow, weather becomes subtle and delayed, and when it is fast, weather becomes violent and fleeting. Even beyond the planets themselves, the idea of weather continues to evolve as we consider moons with atmospheres. Worlds like Titan, wrapped in thick nitrogen skies filled with hydrocarbon clouds where methane plays the role water plays on Earth, evaporating, condensing and raining onto frozen landscapes, carving channels and lakes in ice rather than stone, demonstrating that weather does not require familiarity, only the presence of a fluid capable of changing state and moving energy from one place to another. On Titan, seasons unfold slowly, storms arrive rarely, and rainfall is infrequent but transformative, reshaping the surface over long spans of time, reminding us that weather can be slow and still powerful, rare and still essential, operating on timescales that dwarf human experience yet remain fundamental to planetary evolution. Taken together, these distant atmospheres show that weather is not a single phenomenon repeated across space, but a spectrum of behaviors governed by physics yet expressed through individual planetary circumstances. And this spectrum stretches from the gentle rhythms of Earth to the locked infernos of Venus, from the fragile stillness of Mars to the endless storms of Jupiter, and outward into the delayed reactions of Uranus and the restless winds of Neptune. Weather becomes a diagnostic lens, allowing us to infer what lies beneath the clouds, what kind of heat sources exist, how thick the atmosphere is, how fast the planet spins, and how long it has been cooling since its formation, all without ever touching the surface. In this sense, weather is storytelling, a narrative written in motion and temperature and pressure, revealing chapters of planetary history that would otherwise remain hidden. And as this narrative unfolds across the solar system, a quiet realization begins to take shape, that Earth's weather, so often criticized and feared and misunderstood, represents a narrow balance that few worlds achieve, a balance where energy moves without becoming trapped, where storms form without becoming eternal, where change occurs without overwhelming the systems that depend on it. Earth's weather allows forgetting, allows recovery, allows rest, while elsewhere, weather remembers too much, holds too long, or releases too violently. This contrast reframes our understanding of climate and atmosphere not as background conditions, but as active participants in planetary life, shaping surfaces, influencing chemistry, and determining whether a world remains dynamic or becomes locked into extremes. As we listen to the winds of distant planets and watch storms that outlast civilizations or vanish in weeks without explanation, it becomes clear that weather is not an accessory to a planet, it is one of its defining features, a living expression of energy in motion. We begin to see Earth not as average, but as rare, a place where weather exists in a form gentle enough to support life, yet dynamic enough to sustain it. A world where imbalance never lingers too long, where the atmosphere breathes rather than suffocates, and where the sky remains a place of motion, change, and quiet renewal rather than endless punishment or silence. Here is the continuation written as one single uninterrupted block, 1,400 plus words, no empty lines, calm, slow, and immersive, suitable for long-form narration and sleep listening. As the understanding of weather deepens across these distant worlds, it becomes clear that weather is not simply an outcome of sunlight touching atmosphere, but a long-term negotiation between energy, time, and structure, a process that unfolds differently depending on how patient a planet is willing to be and how much imbalance it can tolerate before motion begins. Across the solar system, planets reveal that weather can be loud or quiet, fast or slow, temporary or almost eternal. And these differences are not random variations, but reflections of deep planetary character, shaped over billions of years. When a planet is massive, its gravity holds atmosphere tightly, allowing storms to grow larger and last longer, while smaller worlds lose their skies more easily, becoming vulnerable to extremes or silence. And this simple relationship between size and gravity quietly determines whether weather becomes a gentle rhythm or a relentless force. On Earth, gravity holds the atmosphere close enough to remain active, but not so tightly that storms become permanent, allowing weather to exist as movement rather than imprisonment. But on giant planets, gravity deepens the atmosphere into vast vertical systems where storms can feed on layers far below anything visible, creating weather that feels less like an event and more like a feature of the planet itself. These storms do not merely pass through space, they belong to it, anchored by pressure gradients and internal heat that renews them endlessly, transforming weather into a geological scale phenomenon that reshapes the atmosphere itself. Rotation speed adds another quiet influence, one that determines whether weather stretches smoothly across a planet or fractures into bands and jets. And here again, Earth occupies a narrow middle ground, rotating fast enough to organize winds, but slow enough to prevent violent fragmentation, while faster rotating giants carve their atmospheres into rigid belts where weather becomes trapped along invisible rails, unable to drift freely, locked into patterns that persist far longer than human history. On slower rotating worlds, weather spreads broadly, blurring boundaries and reducing contrast, leading either to uniform heat, as on Venus, or to weakened circulation, as on Mars, where thin air struggles to move energy efficiently across the surface. These differences reveal that weather is not driven by intensity alone, but by the ability of a planet to redistribute energy. And redistribution requires motion, and motion requires pathways, and those pathways are shaped by gravity, rotation, and atmospheric depth. Over time, these pathways become habits, and habits become climate, and climate becomes destiny, determining whether a world remains dynamic or settles into extremes from which it cannot escape. The longer weather persists in one form, the more deeply it reshapes the planet beneath it, altering chemistry, redistributing materials, and even influencing the future evolution of the atmosphere itself. And in this way, weather is not just responding to a planet, it is actively rewriting it. On Earth, rain erodes mountains and feeds rivers, wind shapes deserts, ice sculpts landscapes, and these processes occur slowly enough to allow ecosystems to adapt and regenerate. But on other worlds, weather's influence may be either too weak to shape anything at all, or so strong that it overwhelms the surface entirely, stripping atmospheres away or burying landscapes beneath endless storms. Mars stands as a reminder of this vulnerability, a planet where weather once may have been more active, where rivers likely flowed and rain may have fallen, but where loss of atmosphere gradually weakened circulation until weather became sporadic and fragile, unable to sustain the processes that once reshaped the surface. In contrast, Venus demonstrates how weather can lock a planet into a single state, where circulation exists but leads nowhere, endlessly recycling the same conditions without relief, preventing change and erasing the possibility of recovery, turning the atmosphere into a prison rather than a mediator. The gas giants reveal a third outcome, one where weather becomes so powerful and persistent that it transcends surface effects entirely, becoming an internal expression of planetary heat and structure, operating independently of external cycles, forming storms that are not disruptions but stable configurations of motion, lasting for centuries without resolution. These outcomes highlight that weather is not inherently beneficial or destructive, but context-dependent, capable of supporting life when balanced, and capable of preventing it when extreme. And this balance is not something a planet chooses, but something it inherits from its formation, its composition, and its position in space. Distance from the Sun determines how much energy arrives, but it does not determine how that energy behaves once it is captured. And this distinction explains why cold planets can host violent storms and warm planets can remain eerily still, because weather is not a thermometer reading. It is a dynamic process shaped by internal and external forces acting together over immense time. As this realization settles, weather begins to feel less like a surface phenomenon and more like a planetary heartbeat, a slow pulse that reveals how a world manages stress, how it responds to imbalance, and how it restores equilibrium when pushed beyond comfort. On Earth, this heartbeat is steady, flexible, forgiving, capable of absorbing shocks and returning to balance, but elsewhere the pulse may be irregular, delayed, or relentless, reflecting worlds that either hold tension too long or release it too violently, as on airless moons where sunlight strikes bare rock and heat radiates away immediately, creating extreme temperature differences between day and night, reminding us that weather exists not because energy arrives, but because something stands between energy and space, creating gradients that drive motion. Without atmosphere there is no weather, only exposure, and without weather, there is no mediation between a planet and its star, only direct impact. This understanding reframes weather not as an inconvenience or a threat, but as a protective layer, a buffer that absorbs energy and redistributes it gently. And Earth's success lies in how well its atmosphere performs this role, neither too thin to fail nor too thick to suffocate. Across the solar system, every variation in weather reflects a variation in this buffering capacity, revealing how close or far each planet lies from the narrow range that allows complexity to persist. Over time, these differences accumulate, shaping planetary futures, locking some worlds into eternal extremes while allowing others to remain dynamic and responsive. And through this lens, weather becomes a long-term evolutionary force, influencing not only surfaces and skies, but the very possibility of change. As the survey of these planetary atmospheres continues, one conclusion becomes unavoidable: that weather is not a universal experience shared equally across worlds, but a spectrum of responses shaped by physics, time, and chance. And Earth's place within that spectrum is neither central nor guaranteed, but rare, a fortunate alignment of conditions that allows weather to exist as motion rather than punishment, as rhythm rather than imprisonment, and as a quiet partner to life rather than an overwhelming force. In recognizing this, the familiar skies above Earth begin to feel less ordinary and more precious, a reminder that the gentle passing of clouds, the coming and going of storms, and the slow turning of seasons are not trivial details but expressions of a planetary balance that few worlds achieve, a balance that allows energy to move without destroying what it touches, and that balance, once seen, becomes something worth understanding deeply, not as background noise, but as one of the most subtle and powerful forces shaping worlds across the solar system. As the journey continues through these varied worlds, a deeper pattern begins to emerge, one that ties all planetary weather together beneath its surface differences, revealing that weather is not merely a reaction to energy, but a form of regulation, a way for planets to cope with imbalance over time, and this regulation can be gentle or extreme, depending on how much stress a planet can endure before it must respond. Energy never arrives evenly, and no planet is perfectly balanced at every moment, so weather becomes the mechanism through which planets negotiate unevenness, redistributing warmth and motion until the system can settle again. And the way this negotiation unfolds tells us everything about a planet's inner tolerance for change. On Earth, this tolerance is flexible, allowing for constant adjustment without collapse. But across the solar system, tolerance varies widely, producing worlds where imbalance lingers, accumulates, or explodes in ways that feel alien when compared to Earth's rhythms. Some planets absorb stress slowly and release it gently. Others hold it until release becomes violent. And still others fail to hold it at all, losing atmosphere and motion until weather becomes little more than a memory written into stone. This spectrum of responses highlights that weather is not a surface feature, but a system-level behavior, one that reflects how deeply energy penetrates a planet and how effectively that planet can move it once it arrives. Atmospheres with depth allow weather to extend vertically, creating layers of circulation that interact across pressure gradients, while thin atmospheres restrict weather to shallow motions that can be easily disrupted or lost entirely. And in both cases, the result is a distinct atmospheric personality that persists over geological timescales. Time itself becomes an essential ingredient, because weather does not operate only in moments or seasons, but across eras, shaping climates that persist long enough to redefine entire worlds. And when a planet's ability to regulate energy shifts even slightly, the consequences may unfold slowly but irreversibly. On Earth, Small changes in atmospheric composition or ocean circulation can gradually alter climate patterns, yet the system remains resilient enough to recover from shocks. But on other planets, similar changes can push conditions past points of return, locking worlds into states that cannot easily be undone. Venus likely once had conditions more similar to Earth's, with moderate temperatures and perhaps liquid water, but a gradual increase in atmospheric density transformed its weather from dynamic to stagnant, from cycling to trapped, until heat accumulation overwhelmed every moderating process, and the planet crossed a threshold from which it could not return. Mars, by contrast, lost atmospheric pressure over time, thinning its sky until weather weakened, water vanished from the surface, and energy flowed directly back into space, leaving behind a planet that remembers weather but no longer experiences it in the way it once did. These histories reveal that weather is not static, that it evolves as planets evolve, responding to changes in mass, composition, magnetic fields, and internal heat, and that the presence or absence of weather at any moment reflects a snapshot in a much longer story rather than a final outcome. Even the gas giants, whose storms appear timeless, are slowly changing, their internal heat fading over billions of years, their atmospheric patterns shifting subtly as energy sources diminish, reminding us that no weather system is truly eternal, only long-lived relative to human timescales. In this way, weather becomes a measure of planetary age, with young worlds often exhibiting intense internal activity, and older worlds gradually settling into quieter states, unless external factors intervene to reintroduce imbalance. Moons orbiting giant planets offer further variation, demonstrating that weather can exist even in the absence of a star's direct influence, driven instead by tidal heating, chemical reactions, or thick insulating atmospheres that trap energy generated internally. Titan, for example, shows that weather does not require warmth in the human sense, only the presence of a substance capable of changing state and transporting energy, and in its cold environment, methane replaces water, forming clouds, rain, and surface features that mimic Earth's hydrological cycle while operating at temperatures far below freezing. This substitution underscores the idea that weather is not defined by specific materials but by processes, by phase changes, pressure gradients, and motion, and that given the right conditions, weather will emerge regardless of how unfamiliar the ingredients may be. Across all these worlds, a unifying principle becomes clear, that weather arises wherever energy is slowed, redirected, or temporarily stored, and that the intensity of weather reflects how difficult it is for that energy to escape. Planets with thick atmospheres slow energy dramatically, producing powerful circulation and long-lasting storms, while planets with thin atmospheres allow energy to pass through quickly, resulting in weaker or rarer weather events. And planets without atmospheres experience no weather at all, only extreme temperature contrasts between light and dark. In this context, Earth's atmosphere acts as an elegant compromise, thick enough to smooth extremes, but thin enough to allow constant renewal, enabling weather to function as a mediator rather than an enforcer. This mediation is what allows life to flourish, because life depends not on the absence of stress, but on the presence of recoverable stress, changes that challenge systems without destroying them, and weather on Earth provides exactly this balance. The realization that weather serves as a form of planetary stress management reframes how we think about storms, winds, and climate, shifting perspective away from seeing them as disruptions and toward understanding them as necessary expressions of balance-seeking behavior. And this perspective extends naturally to the question of habitability beyond Earth. Worlds that cannot regulate energy effectively either accumulate heat until chemistry breaks down, or lose it until motion ceases, and in both cases, complexity struggles to persist. Worlds that achieve moderation, however briefly, create windows of opportunity where chemistry can organize, where cycles can stabilize, and where life may arise, and weather becomes one of the clearest indicators of whether such windows exist. Observing weather on distant planets allows scientists to infer internal heat, atmospheric thickness, and energy flow without landing, making weather a diagnostic tool as much as a dynamic process, a way to read the hidden properties of worlds light years away. As telescopes improve and exoplanet studies expand, weather patterns detected in distant atmospheres may reveal not only temperatures and compositions, but also the potential for balance, hinting at whether a planet is locked into extremes or capable of change. In this broader cosmic context, Earth's weather stands as a reminder that balance is not inevitable, that it emerges from a precise alignment of factors, and that its persistence depends on continuous regulation rather than static perfection. Weather is never finished. It is always responding, adjusting, compensating, and this constant motion is what keeps systems alive rather than fragile. The more we observe weather beyond Earth, the more clearly we see that stability is not the absence of movement, but the presence of effective movement, motion that distributes stress before it can accumulate, and Earth's atmosphere performs this task with remarkable consistency. As this understanding settles, weather begins to feel less like background noise and more like a planetary conversation, an ongoing exchange between energy and structure that never truly pauses. And in listening to this conversation across the solar system, we learn not only about other worlds but about our own, about why Earth remains dynamic yet forgiving, and about how delicate the balance truly is that allows clouds to pass, storms to fade, and skies to clear again and again without ever locking the planet into silence or chaos. As attention drifts deeper into the nature of planetary weather, a quieter truth begins to surface, one that is less about storms and winds and more about patience, about how planets experience time differently from the beings who observe them, and how weather becomes a long conversation stretched across centuries rather than moments, revealing that what feels extreme to us may simply be normal pace to a world that measures change in geological breaths. On Earth, allowing memory to track seasons, storms, and recovery, but beyond Earth, weather often unfolds at speeds that escape human intuition, where decades pass without visible change, and then sudden shifts arrive that feel abrupt only because we were not present for the slow build-up that preceded them. This difference in timescale transforms the meaning of weather entirely, turning it from a daily experience into a background force that shapes planetary identity slowly and persistently, carving atmospheres and surfaces with the same patience that tectonic plates shape continents. Storms that last centuries do not feel permanent to the planet itself. They are simply part of a long adjustment, a steady release of internal energy that has been waiting since the planet's formation. And from this perspective, weather becomes a form of aging, a way for planets to cool and evolve over time. Even on worlds where sunlight plays a minor role, internal heat continues to drive motion long after the star's influence fades, ensuring that weather persists, not because of external forcing alone, but because imbalance remains unresolved deep within. This idea challenges the assumption that weather must be tied to habitability or comfort, instead revealing it as a universal consequence of physics, arising wherever energy gradients exist and matter is free to move. The more closely we observe, the more weather begins to resemble a form of memory, a record of how a planet formed, how fast it cooled, how much atmosphere it retained, and how efficiently it can redistribute energy across its surface and through its depths. In this sense, every storm, Every wind pattern, every persistent cloud band is a clue, a fragment of a story written over billions of years. And by learning to read these clues, we gain insight not only into present conditions but into past states that may no longer be visible. Earth's weather carries its own memory, shaped by oceans that store heat for decades, by ice sheets that respond slowly to change, and by atmospheric chemistry that reflects both natural cycles and recent disturbances, reminding us that even here, weather is not purely immediate, but layered with delays and feedbacks that extend its influence far beyond the moment it is experienced. These delays act as stabilizers, preventing sudden swings from overwhelming the system, and they highlight once again the importance of moderation, of allowing energy to move slowly enough to be absorbed without breaking the structures that depend on it. When these delays are absent or overwhelmed, weather becomes unstable, either freezing into permanence or erupting into violence, as seen on other worlds where balance is either too rigid or too fragile. The concept of feedback becomes central at this stage, as weather systems often reinforce or weaken themselves through loops that either stabilize or destabilize planetary conditions. And understanding these loops reveals why some planets remain dynamic while others drift toward extremes. On Earth, negative feedbacks dominate many aspects of weather and climate. Cooling follows warming, circulation redistributes heat, clouds reflect sunlight, and these processes work together to prevent runaway conditions, while on Venus, positive feedbacks amplified heat trapping until equilibrium was lost, and on Mars, feedbacks favored atmospheric loss until circulation weakened beyond recovery. These contrasting outcomes show that weather is not only a response but a regulator, capable of guiding a planet toward balance or away from it depending on how feedbacks align. As the scale of observation expands beyond the solar system, this framework becomes even more powerful, allowing scientists to interpret weather patterns on exoplanets by identifying whether their atmospheres appear stable, locked, or chaotic, and by inferring whether feedbacks favor moderation or extremes. The presence of clouds on a distant world, the variability of temperature across its surface, the speed of its winds, all become signals of how energy moves and whether that movement supports long-term change or locks conditions into a narrow state. In this way, weather becomes a proxy for habitability without ever referencing life directly, offering hints about whether a planet can support complexity simply by revealing how it manages imbalance. Returning attention to the solar system, it becomes evident that Earth's weather sits within a rare zone where feedbacks cooperate rather than compete, where oceans, atmosphere, and land exchange energy in ways that smooth extremes instead of amplifying them. And this cooperation is not guaranteed to last forever, but it has persisted long enough to allow life to flourish and evolve. This persistence invites reflection not only on how weather works, but on why it matters, why the ability to change without collapsing is so central to planetary stability, and why worlds that lack this ability often appear static, barren, or hostile when viewed from afar. Weather, then, becomes a measure of resilience, of how well a system can absorb stress and return to equilibrium. And this measure applies equally to planets and to the processes that shape them. On Earth, resilience is visible in the recovery that follows storms, in ecosystems that rebound after disturbance, and in atmospheric patterns that re-establish themselves after disruption, demonstrating that weather here functions as a flexible mediator rather than a rigid enforcer. Elsewhere, resilience may be low or non-existent, leading to worlds where change accumulates until collapse, or where stasis prevents renewal altogether. This contrast deepens appreciation for the subtlety of Earth's system, where weather remains active without becoming dominant, and where variability supports rather than suppresses complexity. As the narrative of planetary weather continues to unfold, a philosophical dimension begins to emerge, suggesting that weather is not simply a physical phenomenon, but an expression of balance in motion, a visible sign that a system is alive in the sense that it responds, adapts, and adjusts rather than remaining fixed. This aliveness does not imply consciousness or intention, but it does imply flexibility, a willingness to change direction, to redistribute energy, and to avoid extremes when possible. In this way, weather mirrors broader principles that apply to many systems, both natural and abstract, where stability arises not from rigidity but from the capacity to move, to bend, and to release tension before it accumulates beyond control. The planets that demonstrate this capacity remain dynamic, while those that lack it drift towards states that feel final, whether scorched, frozen, or stripped of atmosphere. Through this lens, weather becomes a lesson in balance, illustrating how systems survive by managing stress rather than eliminating it, and how motion, when properly constrained, becomes a source of stability rather than chaos. As awareness settles into this understanding, the storms and winds of distant worlds no longer feel random or threatening, but purposeful in a broader sense, expressions of physics seeking resolution across vast spans of time. Even the most violent weather, when viewed from this perspective, becomes part of a larger attempt at equilibrium, a necessary release of energy that has nowhere else to go. This realization softens the perception of extremes, framing them as consequences rather than anomalies, and invites a calmer appreciation of the forces shaping worlds beyond Earth. In the quiet accumulation of these insights, weather transforms from a background phenomenon into a central narrative thread connecting planets, histories, and futures, revealing how each world negotiates the same fundamental challenge in its own way: how to receive energy without being destroyed by it, how to release it without losing everything that holds the planet together, and how to exist in motion without ever truly coming to rest. As the understanding of planetary weather settles into something broader and quieter, it begins to feel less like a collection of storms and more like a language spoken slowly by worlds over immense spans of time, a language made not of words, but of motion, pressure, and temperature, repeating the same message in countless variations: that energy must move, and that how it moves determines everything that follows. Across the solar system, this language becomes increasingly abstract, less tied to surfaces and familiar cycles, and more reflective of deep processes unfolding beneath layers of atmosphere and ice, reminding us that weather is often the most visible surface expression of forces that remain otherwise hidden. When a planet's interior is warm, when pressure gradients are strong, when rotation shapes pathways through the sky, weather rises naturally as a release valve, a way for the planet to express internal conditions outwardly without tearing itself apart. This outward expression may take the form of steady winds, immense storms, subtle temperature gradients, or barely perceptible circulation, but in every case it represents the same underlying principle: that imbalance cannot remain silent forever. Earth expresses this principle gently, with clouds that form and dissolve, storms that grow and fade, seasons that return predictably. But other worlds speak more slowly or more forcefully, revealing that weather is not constrained to a single emotional register, but can range from whisper to roar, depending on context. On icy worlds where sunlight barely reaches the surface, weather becomes almost introspective, operating on long delays and subtle contrasts, responding not to daily cycles but to accumulated changes that unfold over decades or centuries, and this slowness gives weather a different texture, one that feels distant from immediate experience, yet deeply influential in shaping planetary evolution. Ice giants and distant moons demonstrate that weather does not require warmth in the human sense, only the presence of energy differences and materials capable of movement, and in these environments, weather becomes an exercise in patience, revealing how slowly change can occur while still remaining inevitable. When methane condenses into clouds on Titan or nitrogen, circulates through thick atmospheres far from the sun, the resulting weather does not rush, does not overwhelm, but quietly reshapes surfaces over time, carving channels, forming lakes, and redistributing material in ways that feel almost contemplative when compared to Earth's rainstorms and winds. This contemplative quality underscores the idea that weather is not defined by intensity but by persistence, by the willingness of a system to keep moving even when change is imperceptible on short timescales. Persistence allows weather to influence geology, chemistry, and climate, aligning with the slow rhythms of planetary processes rather than disrupting them. And in this alignment, weather becomes a bridge between atmosphere and surface, linking sky and ground through motion that unfolds too slowly to be dramatic, yet too steadily to be ignored. As this perspective deepens, the distinction between weather and climate begins to blur, revealing that what we call weather on one world may function as climate on another, depending entirely on timescale and variability. On Earth, climate emerges from the accumulation of weather patterns over decades, but on worlds where weather patterns persist for centuries, the two become nearly indistinguishable, creating conditions where storms define climate rather than contribute to it. This inversion challenges intuitive assumptions, reminding us that definitions based on human experience do not always translate cleanly to planetary systems operating on vastly different scales. Weather then becomes relative, its meaning shaped by observation rather than inherent qualities. And this relativity invites humility when interpreting distant worlds, cautioning against projecting Earth-based expectations onto environments that follow different rhythms. As attention drifts through these realizations, the role of uncertainty becomes apparent, as weather systems, especially on distant planets, often resist precise prediction, their complexity amplified by limited observation and long response times. This uncertainty is not a failure of understanding, but a natural consequence of systems that integrate countless variables over extended periods. Systems where small differences can accumulate into significant outcomes, and where feedback loops may amplify or dampen changes in ways that remain partially hidden. On Earth, this complexity is managed through dense observation networks and models refined over decades. Yet even here, weather retains an element of unpredictability, reminding us that complete control or foresight is neither possible nor necessary for balance. On other worlds where data is sparse and timescales long, unpredictability becomes even more pronounced, reinforcing the idea that weather is not something to be mastered, but something to be interpreted, read as a sign of deeper processes rather than a surface-level phenomenon. This interpretive approach reframes weather as a diagnostic signal, a way to infer internal states without direct access. And it is precisely this quality that makes weather such a powerful tool in planetary science. By observing wind speeds, cloud patterns, temperature gradients, and variability over time, scientists can infer atmospheric composition, internal heat flow, and even aspects of planetary formation, using weather as a proxy for otherwise inaccessible information. In this sense, weather becomes a form of remote sensing, a visible trace of invisible structures, and each storm, each persistent cloud band, each sudden change carries encoded information waiting to be decoded. Beyond scientific utility, however, weather also shapes perception, influencing how worlds are imagined and understood. And it is often through weather that planets acquire their identities in human thought. Venus as a world of endless heat, Mars as a dusty desert, Jupiter as a realm of eternal storms, Neptune as a place of relentless winds. These identities are not arbitrary. They emerge from consistent weather patterns that dominate observation and shape narrative, reinforcing the idea that weather is not merely a background condition, but a defining characteristic of planetary personality. Earth's identity, too, is shaped by weather, by its variability, its capacity for renewal, its cycles of growth and rest, and this identity influences how life perceives and interacts with the planet, embedding weather deeply into culture, language. This embedding underscores the emotional dimension of weather, not as an abstract concept, but as a lived experience, one that connects individuals to broader planetary rhythms and fosters awareness of time passing through cycles of change. When considering other worlds, this emotional dimension fades, replaced by intellectual curiosity and awe, yet the underlying principles remain the same. The weather is an expression of connection, linking energy sources, atmospheric structure, and temporal scale into a coherent whole. As the exploration of planetary weather continues, a sense of continuity emerges, revealing that despite their differences, all worlds participate in the same fundamental process, the redistribution of energy through motion, and that this process, though expressed differently, unites planets across distance and diversity. The Sun may be the common source of energy for many worlds, but the way that energy is handled defines individuality, making weather both a unifying and differentiating force. Through this lens, weather becomes a story of adaptation, of how systems respond to constraints and opportunities, of how balance is negotiated rather than achieved, and of how motion persists even in the coldest, darkest reaches of space. This story does not end with the solar system, but extends outward to countless exoplanets, each with its own version of weather shaped by unique combinations of mass, composition, distance, and history, suggesting that the diversity observed here is only a small sample of what exists beyond. In contemplating this vast diversity, Earth's weather takes on new significance, not as a standard against which others are judged, but as one example among many, notable for its moderation and flexibility, qualities that allow complexity to flourish without overwhelming the systems that support it. This moderation is not guaranteed, and understanding weather as a dynamic regulator rather than a static feature highlights the importance of maintaining balance, recognizing that even small shifts can alter long-term outcomes. It invites reflection on the delicate interplay between stability and change, between motion and rest, and between energy and structure, revealing that weather, in all its forms, is a manifestation of the same fundamental truth, and that how it moves in response determines whether it remains dynamic, collapses into extremes, or fades into silence. As the quiet logic of planetary weather continues to unfold, it begins to resemble less a collection of isolated phenomena and more a continuous spectrum of responses stretching from the innermost worlds to the cold edge of the solar system, but an inseparable part of its existence, woven into its structure, its history, and its future. Every planet carries a memory of how it formed, how quickly it cooled, how much atmosphere it retained, and how efficiently it learnt to move energy away from where it accumulated. And weather is the visible expression of that memory, replayed endlessly in the movement of air, the formation of clouds, and the shifting of pressure across vast expanses of sky. When viewed this way, weather stops being surprising and begins to feel inevitable, the natural outcome of matter responding to energy under gravity, shaped by rotation and constrained by time. On Earth, this inevitability is softened by familiarity, by repetition, by patterns that align with human rhythms, But elsewhere, the same inevitability manifests in forms that feel alien only because they unfold beyond our scale of experience. The recognition that weather is a form of planetary expression invites a deeper appreciation of its role not just in shaping environments, but in maintaining coherence within systems that would otherwise fracture under stress. Without weather, energy would accumulate until structures failed or dissipate until motion ceased, leaving worlds either overwhelmed or inert. And this realization reframes weather as a stabilizing force rather than a disruptive one, even when it appears violent or extreme. Across the solar system, extremes arise not because weather is excessive, but because moderation has failed. Because the mechanisms that distribute energy are either too slow, too weak, or too constrained to keep pace with incoming or internal heat. In these cases, weather becomes intense, not as a cause of imbalance, but as a symptom of it, a visible attempt by the planet to restore equilibrium under difficult conditions. Jupiter's immense storms, Venus's stagnant heat, Mars's fragile dust-driven winds, Neptune's relentless gales, all represent different strategies for managing imbalance, each shaped by planetary properties rather than chance. Understanding these strategies allows us to see weather as adaptive behavior rather than random fluctuation, a process guided by physical laws yet flexible enough to produce a wide range of outcomes depending on context. This adaptability becomes especially apparent when considering transitional worlds, planets and moons that sit near thresholds where small changes can tip systems from one regime into another, altering weather patterns dramatically over long timescales. Earth itself occupies such a threshold, balanced between runaway greenhouse warming and atmospheric loss, and its weather reflects this precarious position, constantly adjusting to maintain equilibrium without locking the planet into a single state. The presence of liquid water amplifies this balancing act, introducing powerful feedbacks that regulate temperature and redistribute energy efficiently, making Earth's weather both dynamic and forgiving. Water's ability to store heat, change phase, and circulate globally through oceans and atmosphere creates a buffering system unmatched elsewhere in the solar system. And this system underpins the stability that allows weather to remain transient rather than permanent. Other worlds lacking such buffers must rely on less efficient mechanisms, resulting in weather that either stagnates or erupts, revealing how critical these mediators are in shaping long-term outcomes. The deeper implication is that weather is not merely an atmospheric process, but a system-level phenomenon that integrates surface, interior, and space into a single dynamic whole, and changes in any one component reverberate through the others over time. On Earth, shifts in ocean circulation influence atmospheric patterns, changes in ice cover alter albedo and temperature, volcanic activity injects aerosols that affect cloud formation, and all of these interactions contribute to a weather system that is responsive rather than rigid. This responsiveness is the hallmark of resilience, the capacity to absorb disturbance and reorganize without losing essential function. And it is precisely this quality that distinguishes Earth from many of its planetary neighbors. As we consider weather across the solar system, resilience emerges as a central theme, highlighting that the ability to change without collapsing is more important than the absence of extremes. Worlds that cannot adapt, whether because their atmospheres are too thick, too thin, or too tightly bound to rigid patterns, tend to drift towards static states that limit complexity, while worlds that maintain flexibility remain dynamic and interesting even if conditions are harsh. This observation extends naturally to the search for habitable environments beyond Earth, where the presence of weather variability may be a more important indicator than average temperature alone. suggesting that worlds capable of cycling energy effectively may be better candidates for sustaining complexity over time. Weather thus becomes a lens through which potential habitability can be assessed, not by seeking Earth-like conditions, but by identifying systems that demonstrate balance-seeking behavior rather than runaway extremes. In this context, storms, winds, and clouds take on new significance, becoming signs of activity and regulation rather than obstacles to comfort, and this shift in perspective aligns with a broader understanding of life as an emergent property of dynamic systems rather than static environments. Life, like weather, thrives on gradients, on differences that drive motion and exchange, and the presence of weather indicates that such gradients exist and are being managed rather than ignored. Even on Earth, ecosystems rely on weather variability to distribute nutrients, trigger life cycles, and maintain diversity, reinforcing the idea that stability without change is not conducive to complexity. This parallel between weather and life underscores their shared dependence on balance and motion, suggesting that weather may be as fundamental to planetary vitality as atmosphere itself. As attention returns to the broader cosmic stage, it becomes clear that the solar system offers only a limited sample of what weather can be, and that beyond it lie countless worlds with atmospheres shaped by different stars, different compositions, and different histories, each producing weather patterns that challenge imagination and expand understanding. Some exoplanets orbit so close to their stars that one side remains perpetually illuminated while the other remains in darkness, creating extreme temperature gradients that drive supersonic winds, while others orbit dim stars that flare unpredictably, subjecting atmospheres to sudden bursts of energy that disrupt circulation and chemistry. In these environments, weather may operate under rules that push the boundaries of known physics, yet still adhere to the same underlying principles of energy redistribution and balance-seeking behavior. Studying such worlds reinforces the universality of weather as a concept, while highlighting the diversity of its expression, reminding us that what feels extreme or impossible from an Earth-centric perspective may be entirely normal under different conditions. This realization fosters humility, encouraging observers to approach planetary weather not as a problem to be solved, but as a phenomenon to be understood on its own terms, free from assumptions rooted in human experience. In this spirit, weather becomes a bridge between disciplines, linking atmospheric science, planetary geology, physics, and even philosophy, as it raises questions about change, persistence, and the nature of equilibrium in complex systems. Weather invites contemplation of timescales beyond human life, of processes that unfold slowly yet inexorably, shaping worlds long after individual events have faded into insignificance. It reminds us that balance is not static but dynamic, maintained through continuous adjustment rather than fixed perfection, and that this dynamic balance is what allows systems to endure rather than shatter under stress. As the narrative of planetary weather approaches deeper levels of abstraction, the focus shifts from specific examples to overarching patterns, revealing that despite immense diversity, all weather systems share a common purpose: to move energy, to relieve imbalance, and to allow systems to persist in the face of constant change. This purpose transcends individual worlds, uniting them within a shared physical framework that governs behavior across space and time. And it is within this framework that Earth's weather finds its place, not as a universal standard, but as one successful implementation among many possible outcomes. Recognizing this place encourages a renewed appreciation for the conditions that allow Earth's weather to remain flexible and forgiving, and a recognition that this flexibility is neither guaranteed nor permanent, but dependent on the continued functioning of regulatory mechanisms that have evolved over billions of years. As awareness settles into this understanding, weather ceases to be a background inconvenience or a distant curiosity and becomes instead a fundamental expression of planetary life, a continuous negotiation between energy and matter that shapes worlds quietly and persistently, revealing their histories, defining their presents, and influencing their futures in ways both subtle and profound. As the long arc of planetary weather continues to reveal itself, attention begins to settle on a deeper stillness beneath all motion, a realization that even the most restless atmospheres are guided by quiet constraints, invisible limits that shape how far imbalance can stretch before it is folded back into the system. And this realization reframes weather not as endless activity, but as a form of disciplined movement, a controlled release governed by boundaries that planets themselves establish through mass, composition, and time. Every gust of wind, every persistent storm, every drifting cloud layer is moving within a framework defined long before it appeared, a framework set by gravity holding atmosphere close, by rotation carving pathways through the sky, by chemical makeup determining how heat is absorbed and released, and by the slow cooling of planetary interiors that continues long after formation. These constraints do not eliminate weather, they give it shape, allowing motion to occur without dissolving the atmosphere into chaos or freezing it into immobility. On Earth, these constraints are finely tuned, allowing weather to express itself freely while remaining contained. But on other worlds, the balance between freedom and constraint shifts, producing atmospheres that either feel locked in place or endlessly agitated, each outcome reflecting how the planet negotiates its own limits. When constraints are too tight, weather becomes uniform and stagnant, repeating the same patterns without variation, as seen on Venus where circulation exists but leads nowhere, endlessly recycling heat under thick clouds without relief. When constraints are too loose, weather struggles to organize, dissipating energy too quickly to sustain motion, as on Mars where thin air cannot hold warmth long enough to maintain consistent circulation. Between these extremes lie worlds where weather becomes monumental, guided by strong constraints that channel motion into vast, stable structures, as on Jupiter and Saturn where gravity and rotation work together to create bands, jets, and storms that persist for generations. These structures feel almost architectural, as though the atmosphere has discovered forms that satisfy its need to move, while respecting the boundaries imposed by the planet, revealing that weather is capable of self-organization on scales far beyond human experience. This self-organization is not conscious or intentional, but it is remarkably consistent, arising wherever conditions allow motion to settle into repeating patterns rather than dissolving into randomness. The presence of such patterns suggests that weather, despite its variability, often seeks states of efficiency, routes through which energy can be transported with minimal resistance, and once found, these routes can persist until underlying conditions change. On Earth, these efficient pathways include jet streams, trade winds, and ocean-atmosphere coupling, all of which evolve over time yet maintain recognizable structure, enabling weather to remain dynamic without becoming erratic. Elsewhere, efficiency may take the form of permanent storms, global circulation cells, or extreme winds that redistribute energy rapidly across the planet, reflecting different solutions to the same fundamental problem. This problem, shared by all planets with atmospheres, is how to handle a constant influx or release of energy without tearing the system apart, and weather emerges as the answer, a compromise between stasis and explosion. As understanding deepens, it becomes apparent that weather is not something layered atop a planet's identity, but something that co-evolves with it, changing as the planet changes, adapting to shifts in internal heat, atmospheric composition, and external forcing over immense spans of time. The weather a planet experiences today may bear little resemblance to what it experienced billions of years ago, and this evolution is written into the atmosphere itself, preserved in isotopic ratios, cloud chemistry, and circulation patterns that hint at former states now long gone. On Earth, evidence of ancient climates is found in ice cores, sediment layers, and fossil records, revealing a weather system that has oscillated between extremes yet repeatedly returned to moderate conditions, suggesting a resilience that has allowed life to persist through upheaval. On other planets, such records may be hidden or erased, but their current weather patterns still offer clues, suggesting whether they are worlds that have settled into final states or ones still in transition. This sense of transition is important because it reminds us that weather is not fixed even on worlds that appear static, and that what we observe is always a snapshot in a much longer narrative. Even Venus, seemingly locked into perpetual heat, may continue to evolve slowly, its atmosphere responding to gradual changes in solar output, or internal processes over timescales too long to observe directly. Mars, though quiet today, still experiences dust storms that hint at residual dynamism, suggesting that weather there has not vanished entirely, but persists in weakened form, a reminder of a more active past. The gas giants, though dominated by immense storms, will eventually cool and change, their internal heat diminishing, their atmospheric patterns shifting subtly as energy sources fade, demonstrating that even the most persistent weather systems are temporary when measured against cosmic time. This temporariness does not diminish their significance. It contextualizes it, placing weather within a continuum of planetary evolution rather than isolating it as a present-day phenomenon. Understanding weather as an evolving system invites reflection on the role of change itself, highlighting that stability does not mean immobility, but the capacity to adapt gradually without catastrophic failure. On Earth, this capacity has allowed ecosystems to respond to shifting climates, reorganizing rather than collapsing, and weather has been the mechanism through which these shifts are communicated and moderated. This communication occurs through subtle signals, changing precipitation patterns, shifting temperature ranges, altered wind flows, all of which convey information about underlying changes in energy balance. Life in turn responds to these signals, adjusting behavior, migration, and physiology to remain aligned with conditions, illustrating a deep coupling between weather and biological systems that reinforces the importance of moderation and variability. Elsewhere, where life as we know it may not exist, weather still performs a similar communicative role, signaling changes within the planet to observers capable of interpreting them. And this universality underscores weather's role as a fundamental aspect of planetary systems rather than a secondary feature. As observation techniques advance, allowing scientists to detect weather patterns on exoplanets, this communicative function becomes even more pronounced, offering insights into worlds that cannot be visited directly, and enabling comparisons that refine understanding of how planets behave under different conditions. The detection of temperature differences between day and night sides of tidally locked exoplanets, the observation of cloud formation on hot gas giants, and the measurement of wind-driven heat redistribution all rely on interpreting weather signals as indicators of deeper processes. Through these interpretations, weather becomes a bridge between observation and theory, linking data to models and models to broader principles governing planetary behavior. This bridge reinforces the idea that weather is not incidental but essential, a core component of how planets interact with their environments and with their stars. As this perspective takes hold, the focus shifts from cataloguing extreme phenomena to understanding underlying patterns, from marveling at alien storms to recognizing the shared physics that produce them, and from viewing weather as an obstacle to comfort to appreciating it as a necessary function of planetary balance. This appreciation does not diminish the power or danger of weather on any world, but it situates that power within a context that emphasizes purpose rather than threat. Storms release energy that would otherwise accumulate. Winds redistribute heat that would otherwise concentrate. Clouds regulate radiation that would otherwise destabilize the system, and together these processes maintain motion within survivable bounds, even when conditions are harsh. Earth's relative comfort arises not because its weather is weak, but because it is well regulated, constrained by feedbacks that prevent extremes from dominating indefinitely. Recognizing this regulation invites a more nuanced understanding of climate, one that acknowledges vulnerability without assuming inevitability, and that values the mechanisms that allow adjustment, rather than focusing solely on outcomes. Weather becomes a lens through which to view balance, revealing how systems manage stress and how that management determines long-term stability. This lens applies not only to planets but to many complex systems, suggesting broader lessons about resilience, adaptability, and the importance of allowing motion rather than resisting it. As the narrative continues to unfold, the sense of weather as a universal process becomes increasingly clear, uniting diverse worlds through a shared need to move energy, to respond to imbalance, and to evolve over time. This unity does not erase difference, it highlights it, showing how varied the solutions can be when the same problem is approached under different constraints. Earth's solution happens to support life, but it is not the only solution, nor is it guaranteed to persist unchanged. Understanding weather as an evolving regulator rather than a static feature deepens appreciation for its role in shaping planetary futures and encourages a calm, patient observation of its patterns rather than a reactive response to its fluctuations. Weather reveals itself as both dynamic and disciplined, restless yet constrained, endlessly variable yet guided by quiet rules that ensure systems do not drift too far from balance. And it is within this interplay of motion and constraint that the true character of planetary weather emerges, not as chaos, but as a measured response to the eternal challenge of energy in motion. As the exploration of planetary weather approaches its quiet culmination, attention naturally turns inward, not toward any single planet, but toward the idea that weather itself is a mirror, reflecting how systems respond when they are allowed to move, rather than forced to remain still. And in this reflection, patterns begin to feel less alien and more familiar, even when they unfold on worlds unimaginably distant from Earth. Across the solar system, every atmosphere tells the same basic story in a different accent, but a consequence of existence in motion, a response to energy that cannot remain where it arrives, and this response carries meaning whether it manifests as gentle clouds or endless storms. When viewed from this perspective, weather becomes a kind of honesty, a visible expression of internal conditions that cannot be hidden or ignored. And it is this honesty that allows observers to infer so much about planets they will never touch. A calm sky does not always indicate balance, just as a turbulent one does not always indicate instability. And learning to read weather requires patience, an understanding that appearances can mislead unless they are placed within a broader context of time, scale, and structure. Earth's skies feel alive because they change, because clouds form and dissolve, because storms arrive and leave, and this change reassures us that the system is working, that energy is being moved and released rather than trapped. But elsewhere, stillness may conceal imbalance, and motion may signal survival rather than danger. Venus's uniform heat, Mars's thin silence, Jupiter's endless storms, Neptune's relentless winds, all challenge intuition, yet each represents a consistent response to conditions that have persisted for immense spans of time, reminding us that weather does not exist to serve comfort. This realization strips weather of moral judgment, revealing it as neither good nor bad, but necessary, a process that unfolds whether or not it aligns with human preference. As this neutrality becomes clearer, a deeper appreciation emerges for Earth's weather, not as something inherently superior, but as something fortunate, a configuration that happens to align with the needs of life, while remaining subject to the same physical rules that govern all worlds. Earth is not exempt from imbalance. It manages it well, and this management depends on feedbacks that operate quietly. Oceans absorbing heat, clouds reflecting sunlight, winds redistributing energy, and ice moderating extremes, all working together without coordination or intent, yet producing a system that feels coherent and forgiving. This coherence is not permanent, and recognizing its fragility invites a more attentive relationship with weather, one that acknowledges its role as a regulator rather than treating it as background noise. When weather is understood as regulation, its fluctuations become signals rather than surprises, indicators of how energy is flowing through the system and whether balance is being maintained or strained. On Earth, these signals are subtle yet persistent, reminding observers that stability is maintained through constant adjustment rather than fixed equilibrium, and that ignoring these adjustments can allow small imbalances to grow into larger ones over time. Across other worlds, the same principle applies, though the signals may be dramatic or delayed, revealing planets that respond slowly or violently, depending on how much energy they can hold before releasing it. This relationship between storage and release emerges as a central theme, showing that weather intensity often reflects not the amount of energy present, but the difficulty of releasing it smoothly. Planets that release energy gradually experience weather that feels gentle even when it is powerful, while those that release energy abruptly experience extremes that dominate perception. Earth's oceans play a crucial role in moderating this process, storing vast amounts of heat and releasing it slowly, smoothing transitions and preventing sudden shifts, a role that few other worlds can replicate. Without this buffering capacity, atmospheres must rely on less efficient mechanisms, leading to weather that either stagnates or erupts, reinforcing the importance of internal reservoirs in shaping atmospheric behavior. The recognition of these reservoirs extends beyond water, encompassing any medium capable of absorbing and redistributing energy, whether it is thick gas layers on giant planets or chemical processes within dense atmospheres, highlighting that weather depends as much on what lies beneath the sky as on what happens within it. As understanding deepens, the distinction between internal and external drivers of weather becomes increasingly blurred, revealing that planets are not passive recipients of energy, but active participants in shaping how that energy moves, storing it, redirecting it, and releasing it according to their own constraints. This agency is not conscious, but it is structured, governed by mass, composition, and history, and it ensures that weather remains a meaningful expression of planetary identity rather than a random overlay. When considering the immense variety of weather across the solar system, it becomes tempting to categorize worlds into simple types, hot or cold, stormy or calm, but such categories quickly dissolve under closer inspection, revealing gradations and nuances that resist easy classification. Even planets that appear similar in size or composition can exhibit radically different weather patterns due to subtle differences in rotation, atmospheric chemistry, or internal heat, demonstrating that weather is sensitive to initial conditions and capable of diverging dramatically over time. This sensitivity echoes principles seen in other complex systems, where small differences can lead to large outcomes, and it reinforces the idea that weather, like many natural processes, operates on the edge between order and chaos, organized enough to persist, yet flexible enough to change. Earth occupies a particularly stable position within this spectrum, but stability should not be mistaken for permanence, and recognizing this encourages a long-term view that appreciates weather as an evolving phenomenon rather than a static backdrop. Over geological timescales, Earth's weather has shifted repeatedly, adapting to changes in solar output, continental configuration, and atmospheric composition, and each shift has left traces in the planet's record, demonstrating that moderation itself is dynamic, achieved through continual recalibration rather than fixed conditions. This recalibration underscores the importance of responsiveness, the ability of a system to adjust gradually rather than resisting change until collapse becomes inevitable. Across the solar system, worlds that lack this responsiveness tend to settle into extremes, while those that retain it remain dynamic, even if conditions are harsh. This pattern suggests that weather variability may be a more reliable indicator of long-term planetary health than absolute measures of temperature or pressure, as variability implies active regulation rather than stagnation. In this light, weather becomes a sign of ongoing negotiation, a process that reveals whether a planet is still actively managing energy or has ceased to do so effectively. Observing weather, therefore, becomes an act of listening, of tuning in to the subtle signals that indicate how a world is coping with the demands placed upon it. And this listening requires patience and acceptance that meaningful change often unfolds slowly, beyond immediate perception. As the narrative draws closer to rest, the idea of weather as conversation becomes increasingly resonant, suggesting that planets are constantly speaking through motion and change, sharing information about their state with any observer willing to interpret it. Earth speaks softly through passing clouds and shifting seasons, while other worlds speak more loudly or more slowly, yet all participate in the same dialogue, bound by the same physical laws. This shared dialogue unites diverse worlds within a common framework, revealing that despite immense differences, all planets face the same challenge of managing energy in motion, and all develop weather as their answer. In recognizing this unity, the diversity of weather becomes less overwhelming and more harmonious. Each variation a different solution to the same problem, rather than an anomaly to be explained away. This harmony invites a calm acceptance of difference, a recognition that there is no single correct way for a planet to behave, only ways that are consistent with its nature and history. Earth's way happens to align with life as we know it, but it remains one expression among many, shaped by chance and constraint rather than destiny. As awareness settles into this understanding, weather begins to feel less like an external force acting upon worlds and more like an internal rhythm expressed outwardly, a steady pulse that reflects how systems maintain coherence in the face of constant change. This pulse is slow enough to be soothing, even when it manifests as storms, because it follows patterns that, when viewed from a distance, reveal order rather than chaos. The realization that weather, in all its forms, is an expression of balance in motion offers a quiet sense of continuity, connecting distant planets through shared principles and reminding observers that change does not imply instability, and that motion, the restless winds of Neptune, the eternal storms of Jupiter, the silent heat of Venus, and the gentle cycles of Earth all find their place within a broader tapestry, one that speaks of energy flowing through matter, of systems adapting to constraints, and of worlds enduring through movement rather than stasis. And it is within this tapestry that the story of planetary weather reaches its calmest point, not by resolving into certainty, but by revealing that uncertainty itself is a natural and manageable aspect of existence in motion. As the long journey through planetary weather gently comes to rest, what remains is not a list of facts or comparisons, but a feeling, a quiet understanding that weather is less about spectacle and more about continuity, less about events and more about process, a slow unfolding that connects worlds across space and time through the shared need to release imbalance without breaking apart. Every atmosphere we have considered, from the familiar skies of Earth to the restless winds of distant planets, has revealed the same truth in different forms, that energy never remains where it arrives, and that motion is the only way systems survive the constant pressure of existence. This motion does not rush, and it does not aim for perfection. It simply continues, adjusting endlessly, shaping worlds not through intention, but through persistence. On Earth, this persistence is gentle enough to feel comforting, a background rhythm that allows life to settle, adapt and grow, but elsewhere it may feel overwhelming or alien, reminding us that comfort is not a requirement of physics, only balance is. The storms that never end, the winds that never slow, the skies that never clear are not mistakes in the system. They are the system, functioning exactly as conditions demand, expressing planetary identities that formed long before observation and will persist long after it ends. Seen this way, weather becomes an expression of patience, a willingness to move energy slowly rather than violently when possible, and to release it forcefully only when no other option remains. This patience is what allows some worlds to remain dynamic rather than static, even when conditions are harsh, and it is what allows others to endure extremes without collapsing into silence. Across the solar system, weather reveals which worlds are still negotiating balance and which have settled into states where negotiation has ended. And this distinction matters, because negotiation implies possibility, while final states imply limitation. Earth remains a world of negotiation, where feedbacks continue to operate, where oceans and atmosphere exchange heat, where clouds form and dissolve, where seasons pass and return, and this ongoing dialogue creates space for recovery, for renewal, and for rest. Rest, in this context, is not the absence of motion, but the presence of reliable rhythm, motion that can be anticipated, absorbed, and lived within without fear of permanence or sudden collapse. When storms pass and skies clear, when heat disperses and cold retreats, the planet demonstrates that it knows how to let go. And this ability to let go may be the most important characteristic of any stable system. Elsewhere, where letting go is impossible or delayed indefinitely, weather becomes a form of tension held too long, and tension held too long eventually reshapes everything it touches. Venus teaches this through endless heat, Mars through fragile silence, Jupiter through storms that outlast memory, Neptune through winds that never truly rest. And each lesson reinforces the idea that balance is not static, but earned through continuous adjustment. As the mind absorbs this understanding, weather begins to feel less external and more internal, not just something that happens to planets, but something that planets do, a behavior rather than a condition, a way of coping with existence under constant energy flow. This reframing invites a softer relationship with weather on Earth as well, one that recognizes storms and shifts not as interruptions, but as expressions of a system doing what it must to remain whole. Even discomfort becomes meaningful within this frame, not something to be eliminated entirely, but something that signals movement, change, and release, a reminder that stagnation would be far worse. In the vastness of space, planets that no longer experience weather in any recognizable form appear quiet, even peaceful. Yet this peace is deceptive because it often reflects a loss of flexibility rather than the presence of harmony. Without atmosphere, without circulation, without motion, energy strikes and leaves without mediation, creating extremes that cannot soften over time. And this absence of weather marks the end of negotiation, the end of responsiveness, the end of possibility for complexity. Weather, then, becomes a sign of life in the broadest sense, not biological life necessarily, but systemic life, the ability of a world to respond, adapt, and adjust rather than remain fixed. This systemic life does not require consciousness or intention, only the capacity to move energy through layers of matter without tearing itself apart. And wherever that capacity exists, weather follows naturally. The gentle passing of clouds on Earth, the slow drift of bands on Jupiter, the delayed storms of Uranus, the fleeting darkness on Neptune, all represent the same fundamental act, energy finding a path forward. As awareness settles into this shared foundation, differences between worlds feel less isolating and more harmonious. Variations on a theme rather than contradictions, each planet playing its own version of the same quiet melody, shaped by mass, distance, composition, and time. This melody is not meant to be followed closely or analyzed endlessly. It is meant to be felt, allowed to fade into the background, where it can soothe rather than stimulate, reminding listeners that movement does not require attention to remain effective. Just as the ocean continues to circulate heat beneath the surface whether or not it is observed, planetary weather continues its slow work regardless of awareness, carrying energy from where it accumulates to where it can finally rest. There is comfort in this independence, in knowing that systems larger than any individual continue to function without supervision, allowing attention to relax and drift without consequence. As the journey through planetary weather gently closes, there is nothing left to resolve, nothing left to compare, nothing left to hold on to tightly. The knowledge has already settled, integrated quietly, not as information to recall, but as perspective, a subtle shift in how the world is understood. Weather is no longer just rain or wind or storms, but a universal response to imbalance, a slow choreography of energy moving through matter, shaping worlds patiently over time. This understanding does not demand action or vigilance. It invites trust. Trust that motion can be steady without being violent, that change can occur without catastrophe, and that balance does not require perfection, only persistence. In this trust, the mind can release its grip, allowing thoughts to soften and drift, much like clouds thinning after a long storm, revealing clear sky not as a final state, but as a moment of quiet between movements. The planets continue their journeys, their atmospheres continue to move, their weather continues to negotiate energy in its own way, and nothing about this process requires attention to continue. Rest becomes possible not because motion has stopped, but because motion has become predictable, reliable, and safe to ignore. In this space, awareness can fade gently, carried not by silence but by the steady hum of systems doing what they have always done, adjusting, balancing, releasing, and enduring. And as sleep approaches, it does so not as an ending, but as another form of regulation, another quiet process that redistributes energy within the body, just as weather redistributes it across worlds, reminding us that rest, like weather, is not an absence of activity, but a deeper kind of movement, one that continues softly, patiently, and without demand, long after attention has drifted away. As everything slowly settles, there is nothing left to search for, nothing left to explain, only the quiet understanding that motion continues whether it is noticed or not, and that the universe has never required attention in order to remain balanced, because balance is not an achievement but a process, unfolding patiently through time without urgency or expectation. The winds on distant planets continue to move, clouds continue to form and dissolve, storms continue to rise and fade, not because they are being observed, but because energy must always find a way to flow, and this flow is older than curiosity, older than language, older than memory itself. In this realization, the need to follow each idea loosens, and understanding becomes something that can be felt rather than held, something that remains even as focus softens and thoughts grow less defined. Weather across the solar system in all its variations does not ask to be understood completely, only to be acknowledged as a natural expression of worlds responding to existence, negotiating imbalance quietly, endlessly, without judgment or intent. Each planet continues its own slow conversation with energy, some speaking through endless storms, others through stillness, others through delayed responses that unfold over centuries, and none of these conversations require resolution, because they are not questions seeking answers, but processes sustaining themselves through motion. Earth's weather continues as well, clouds passing overhead, winds shifting direction, temperatures rising and falling, all of it happening gently enough that it can fade into the background, becoming part of the atmosphere of rest, rather than a source of attention. The planet knows how to release what it holds, just as the body knows how to release tension when allowed, just as the mind knows how to loosen its grip when it no longer needs to stay alert. There is comfort in recognizing that these processes are not fragile, that they do not depend on constant awareness, and that even when attention drifts away, the systems that sustain balance remain steady and reliable. The oceans continue to circulate heat beneath the surface. Unseen and unhurried, the atmosphere continues to redistribute energy across the sky, and the slow turning of the planet continues without pause, carrying day into night and night back into day with quiet consistency. Nothing here is rushed, and nothing here is unfinished, because the work of balance is never meant to be completed, only continued, and this continuation is gentle enough to allow rest. As thoughts begin to soften, it becomes easier to sense that understanding does not disappear when focus fades, it simply changes form, becoming part of a broader awareness that no longer needs to analyze or compare. The storms of Jupiter, the winds of Neptune, the silent heat of Venus, and the fragile skies of Mars all exist within the same universal rhythm, one that moves energy without concern for comfort, yet produces moments of harmony simply by following its own rules. Earth's place within this rhythm feels calm, not because it is separate, but because it has found a way to move energy slowly enough to support complexity. And that slowness is something the body and mind can mirror. Breathing becomes quieter without instruction. Muscles release without command. Thoughts drift without direction. All following the same principle that governs weather, that movement does not need effort when pathways are clear. There is no need to hold on to any single idea now, because the story has already done its work, not by delivering conclusions, but by creating space for perspective, space for calm, space for release. The planets continue to exist whether they are imagined or not. Their atmospheres continue to move whether they are named or forgotten, and this independence offers reassurance, a reminder that nothing essential depends on vigilance. Just as the night sky remains even when eyes are closed, the systems that shape worlds remain even when attention fades, carrying on with quiet reliability. In this awareness, rest feels less like stopping and more like joining a slower current, one that carries everything gently forward without resistance. The universe does not rush toward endings, and neither does the body when it is allowed to slow naturally, finding its own rhythm without interference. As the final thoughts dissolve, they do not disappear abruptly, but thin gradually, like clouds dispersing after a long storm, leaving behind a sense of openness rather than emptiness. There is nothing left to resolve, because balance is not something that needs to be solved, only trusted, and trust grows easily in the presence of steady motion. Weather, in all its forms, teaches this lesson quietly, showing that change does not have to be dramatic to be meaningful, and that stability does not require stillness to exist. The gentle movement of energy across worlds mirrors the gentle movement of awareness as it drifts towards sleep, both following natural gradients rather than imposed direction. In this shared motion, there is no boundary between understanding and rest, only a gradual transition from active attention to passive presence. The planets continue their slow journeys around the sun, their atmospheres continue to breathe, their weather continues to negotiate energy, and nothing about this ongoing process demands engagement. It is safe to let go, safe to drift, safe to rest within a universe that has been balancing itself long before observation and will continue long after it ends. As sleep approaches, it does so not as a break from the world, but as another expression of the same principle. Energy redistributing itself quietly, systems recalibrating without effort, motion continuing beneath stillness. And in this gentle continuation, there is nothing more to say, nothing more to follow, only the steady assurance that balance persists, that movement remains kind, and that rest is already underway, unfolding naturally, patiently, exactly as it should.